Hello students, in this video on quadrilaterals, we will be doing sum number 1 and 2 of practice set 5.4 and sum number 1 and 3 of practice set 5.5. So let us begin with the first sum of 5.4, which says in quadrilateral IJKL, side IJ is parallel to side KL, angle I is 108 degrees, angle K is 53 degrees, then find the measure of angle I and angle L. So now in this, for the solution, quadrilateral IJKL, it's given that only one side is parallel. If only one pair of opposite side is parallel, that means the quadrilateral is a trapezium. So let's have the trapezium here. Now here it is given that IJ is parallel to KL. Now according to this figure, these are the parallel sides. So this would be IJ and this would be KL. So now with using this, we are going to, with the measurements given, we will find the measure of angle J and angle L. Now it is given that IJ is parallel to side KL, IJ parallel to KL. So we know that the interior angles will be supplementary. That means angle J plus angle K will be equal to 180 degrees. So, because the interior angles are supplementary. Let's substitute the value of K here. So, angle J plus 53 degrees will be 180 degrees. So, on solving this further, we will get J is equal to 180 minus 53 equal to 127 degrees. Therefore, I can say that J is equal to 127 degrees. Similarly, we can find the value of angle L. So again we will take the sides parallel because it's given. So we know the interior angles I plus angle JL will be equal to 180 degrees. So let's write it. So substituting the value of angle I as 108 degrees, we will get the value of angle L. So L will be 180 minus 108, which is equal to 72 degrees. So we have got angle L as 72 degrees. So let's write the final answer. That is angle J is equal to 127 degrees and angle L is equal to 72 degrees. Let's go to the next question of practice at 5.4. That's the second one. In quadrilateral ABCD, side BC is parallel to side AD and AB is congruent to DC. If angle A is 72 degrees, then find the measure of angle B and angle D. Now here in this question, children, the one side is given, one pair of opposite side is given parallel and the other pair of opposite side is given congruent. That means the same pair is not parallel and congruent. So it is not a parallelogram. And since only one side is given parallel, it has to be a trapezium. Okay, so let's have the solution. So this is a trapezium in which BC is parallel to AD. So these are the parallel sides. So this will be BC. So this has to be AD. Now same like the previous sum, since A is given, we have to find measure of angle B and angle D. So let's start with it. BC is parallel to AD, so angle A plus angle B will be equal to 180 degrees because interior angles are supplementary. Substituting the value of A as 72 degrees, we'll get the value of B to be 108. So out of the two angles that are asked, we have got B. Now we need angle D. Now what else is given in the question? It is given that AB is congruent to DC. That means this is an isosceles trapezium. So quadrilateral ABCD is an isosceles trapezium. Now, in an isosceles trapezium, the base angles are equal. So we'll write angle A will be congruent to angle D. And these are the base angles. Even B is congruent to C. But we need only to find out D. So I have marked here A and D. So let's write angle A will be congruent to angle D. Base angles of an isosceles trapezium are congruent. So therefore I can say that angle D will be equal to angle A equal to 72 degrees. So therefore D will be 72 degrees. So we have got whatever was asked. We have found out. So let's write the final answer that angle B is equal to 108 degrees and angle D is equal to 72 degrees. Hope this part is clear, students. Now we go to practice set 5.5. Now this exercise is based on midpoint theorem, okay, which we have already learned. So let us start with the first question. In figure 5.38, points x, y, and z are the midpoints of side AB, side BC, and side AC of triangle ABC respectively. AB is 5 centimeters, AC is 9 centimeters, and BC is 11 centimeters. Find the length of XY, YZ, and XZ. So let's have the figure. This is the figure. Now students, here we have to find out three lengths: XY, YZ, and XZ. Now to first start with XY's, I am going to start with this. So I will take X and Y as a midpoint first. Okay. So I start with the solution. To first find XY, I will take X is a midpoint and Y is a midpoint. So it's given. So I write points X and Y are the midpoints of side AB and side BC. X is the midpoint of AB and Y is the midpoint of BC. It's given. So therefore I can say that XY will be half of AC. So that is midpoint theorem. So I substitute XY is half of AC. That's midpoint theorem. So we know the value of AC. AC is 9. So I'll substitute the value of AC and I'll get the value of XY as 4.5 centimeter. Okay, now we will find the length YZ. Now to start with YZ, same way we will proceed. When I had to find XY, I took X and Y as the midpoints. Now when I have to find YZ, I will take points Y and Z as the midpoints. Okay, so my statement will be points Y and Z are the midpoints of BC and side AC respectively. The same steps we have to repeat. So therefore I can say that YZ will be equal to half of AB. So let's write that step. Now we know the value of AB, so we will substitute AB as 5 and we'll get the value of YZ equal to 2.5 centimeters. Now we go to find the third length, that is XZ. Now to find XZ, I will take X and Z. So we'll take points X and Z are the midpoints of side AB and AC respectively. So I will say that XZ is half of BC. Again, the reason is midpoint theorem. So let's substitute the value of BC as 11. So we get XZ as 5.5 centimeters. Now let's write the final answer. XY is 4.5 centimeters, YZ is 2.5 centimeters, and XZ is 5.5 centimeters. Hope the solution is clear. Now on the similar basis, we have the third sum. Okay, so we'll take the third sum. This is a proof. In this figure, in figure 5.40, triangle ABC is an equilateral triangle. Points F, D, and E are the midpoints of side AB, side BC, and side AC respectively. Show that triangle FED is an equilateral triangle. So let's have the figure. Now the solution would be same like how we did in the previous question. Okay, we will take two midpoints at a time and write the proof. So we'll first start with points F and E. Points F and E are the midpoints of AB and AC respectively. So we can say that FE is half of BC. That's midpoint theorem. Okay. Now since we don't have the values, we'll leave the step as it is. Now we'll take the next pair. So let's take now F and D. Points F and D are the midpoints of AB and BC respectively. So we can say that FD is half of AC. Okay. Same way we'll go to the last pair, that is E and D. Points E and D are the midpoints of AC and BC respectively. So we can say that ED is half of AB. Now we know that it is given that triangle ABC is an equilateral triangle. So we can say that all the three sides are equal. AB is equal to BC equal to AC. So I can write half of AB is equal to half of BC equal to half of AC, multiplying by half throughout. So half of AB is ED. half of BC is FE from this step, and half of AC is FD. So instead of half, I'm going to write this as ED equal to FE equal to FD from 2, 4, 6 and 8. Now ED is equal to FE equal to FD. Now ED is this line, ED is equal to FE equal to FD. That means this triangle, in triangle FED, all the sides are equal. So we can say that triangle FED is an equilateral triangle. Okay, hope the solution is clear, students. That's all for the day. Thank you.